That's good, I can even see it down there. Good afternoon, everybody. My name's Chris Jones from Novalia. After just a bit of messing around with the presentation. My company, Novalia, it's a small team based in Cambridge in the UK. We're developing ways of printing functional electronics through traditional printing processes. So what I'm going to do today is show you through a little bit of the background of the company, where we're coming from, our particular approach to printed electronics, and then draw you through some examples of customer projects or demonstrator projects that we've done. So first of all, who we are. We're based in Cambridge in the UK, a small team of 7 of us in the office, usually most of the time. A couple of people we work with outside of the company who help support some of what we're doing. We were founded in 2006 by Kate Stone, who came out of Cambridge University with some interesting ideas, worked for a small time for a technology startup in Cambridge, and then discovered print as a manufacturing process. Now, Kate's background was entirely electronics and electronic engineering, and she started to come up with some interesting ideas about how to methods of printing transistors and being able to deposit down using flexo or gravure processes functional materials in really interesting ways. She set up a clean room in her garage back in 2007 and started to try and find ways of printing functional transistor arrays, which was interesting. Then she saw a little bit of an opportunity in trying to do things slightly less sophisticated, and started Novalia off and started bringing in a team. The team are all from very, very different backgrounds. So within the tiny team, we have a couple of electronic engineers. We've got a software engineer. We've got a couple of designers. Kate's obviously from an electronic science background. And my own background is the print and packaging industry for the last 20 odd years. It's only through having all of these skills together under the one roof in the same team that we're able to achieve some of what we've been doing. Best way of explaining what we do is to take you through, this is a project from many, many years ago, to take you through a project and a client briefing and how we address their particular challenge. So the client in this instance was a tissue manufacturer, a US tissue manufacturer, and we'd shown them some demonstrators. This is back in about 2009. We'd show them some demonstrators, some examples of the technology we were using, and they said, right, well, we'll give you a brief. We'd like you to develop a concept. We'd like you to develop a demonstrator as to how you'd address the brief. The brief was, there's a customer driving 50 miles and stopping at a gas station. That customer's got a child in the back seat of the car. When they're going in to pay for the gas or the fuel for the car, how could we put some type of technology onto the packaging that would affect the customer's decision on picking up their product rather than a competitor's product at the point of sale? And then they also threw in this really interesting thing. Bear in mind, this is a few years ago. They said, we'd like you to find a way of connecting the package with the internet as well, which we knew what they were asking, but then we addressed that particular challenge in our own way. So again, within the team, the designers and the graphic designers decided they're creating the consumer experience, so it's not just a case of designing the graphics, it's what happens if and what happens when. Within the team, the electronic engineers were designing what the electronics module would have to do, what components need to go on there and to get that manufactured. Similarly, my background being printing inks, how were we going to print it, where were we going to get it printed, what inks were we going to use. So, on top of designing the electronics module, we need some software to sit on the chips that we're using. So, our software engineers writing the software to try and realize the designer's consumer experience flow. You can see a printing press there. That's the back end of the printing press where the print's coming out. We're printing a conductive circuit. To the circuit, we're attaching electronic components, traditional electronics components. I'm quite used to measuring color at the back of a press and assessing the print at the back of a printing press. Similarly, all of a sudden I've got a multimeter in my hand and I'm measuring the conductivity of inks as well. And the output from this particular project, hopefully this will work. Hopefully the audio will come out as well. It was the world's first piano on the side of a tissue box. That's meant to be delivered with humour. But the client absolutely loved it. It was never designed to go into full production. It was a case of proving what we could do and how designing an experience works. So taking into account the original brief, the piano was designed all with different colour-coded keys so that the 5-year-old in the back of the car was able to recognise the different keys as different colours. And there's a series of lyrics printed on the side of the carton that, according to the words for the song, they're able to recognize what key to play from the color it is. So anybody can play it apart from if they're colorblind. Similarly, I'm the parent of a 5-year-old child myself, and it's amazing how quickly Twinkle Twinkle Little Star gets very, very annoying. So a method of connecting to the internet was to put further songs available online and color-coded songs available online from a web page where you go to the web page and it gives you alternative content. Print processes. So we're using existing traditional print processes. We're using digital print in many cases for some of the demonstrator runs, for some of the graphics that we're putting onto the functional circuits. But the key thing that we're using at the moment, it's screen printing, flexo printing, offset printing. I include gravure up there, but in truth, I've not got to the volumes and things that we're doing to justify actually getting onto a gravure press. But the key thing is these are unmodified processes. These are actual real machines. I don't own a printing press. We've no intention of buying a printing press ourselves. Our entire vision is there's an entire print industry out there that's more than capable of doing all the things that we're developing. So if we're not pushing the limits of the process, if we're not trying to print too fine a line with flexo or trying to push the amount of weight we're piling on with the litho process, if we're keeping within sensible manufacturing tolerances for what we're asking of the process, theoretically, all the things we're doing can be printed anywhere in the world. So we're printing conductive inks down, usually on the reverse of the substrate. Onto the print, we're attaching what we call electronic components, but it's traditional electronics. It's a technology that sits within McDonald's toys. So what we're doing, we can print capacitive touch. So we can print areas behind the printed posters or the printed article that recognises the presence of your hand there and sends a signal to the electronics. We can mount LEDs. You can see on the transparent print to the left-hand side, that's a PET print, printed with conductive circuit with LEDs mounted onto it directly. We can put speakers or attach speakers, and I'll show you some examples in a moment, where a combination of capacitive touch generates audio. Similarly, the capacitive touch can be linked up to interesting wireless communication, and I'll show you a couple of examples in a moment. But the key thing is, it's entirely the art of the possible. It's traditional print, it's traditional electronics, and we're bringing them together in a quite unusual way. Presentation earlier on was entirely about patents and IP. We file IP in areas where we come across a problem, a challenge. There's been quite a number of challenges with how you attach a printed circuit board to a piece of conventional print when the two things weren't designed to go together. So methods of enabling some of the things we do as we run into challenges nobody's experienced before, we'll file patents in that area. The other bulk of our IP is entirely around the know-how, in that whilst I'm going to show you a series of demonstrators and examples today, it's taken a lot of things that I'm not showing you and failures to get to the point where we are. This is the first project I worked on with Intercolor. This was interesting because it was a litho printed poster. So we can do a lot of things with screen print. This was litho printed on a standard Komori press, nothing special about it. So there's capacitive touch points printed on the reverse. Thanks. I have to spend my time in the office with these noises behind me all the time. So there's capacitive touch points, there's printed conductive panels printed directly onto the substrate on the back of that piece of paper. This is a few years ago, so no bones about it. You can see a couple of wires coming down off the left-hand side of the poster. Those are going to a fairly large speaker and a fairly large set of batteries. And I'll show you how we address that later on. I was particularly proud because we were printing this, as I say, using the litho process at some quite thin application weights. So the conductives are going down an ordinary conventional litho process. This is a project we've still got ongoing, so all of the examples I'm showing today are things that I can show you. We do many projects with clients that end up being confidential, and being quite frank, they're usually very exciting and very interesting, but I'm not able to show them. This is a project we started off with a client, and then they've since allowed us to talk about what we're doing. It's still ongoing. A lot of what we're doing is novel, is ephemeral, is exciting, it's novelty, it's gimmick. There are some applications we're working on that are, have genuine functional applications. So this is a piece of pharmaceutical packaging. You can see on the blisters that there's some conductive tracks printed. The entire idea is that the pharmacist can pre-program the packaging with your dosage of the drugs you're supposed to be taking, the times when you're supposed to be taking them. The packaging gives you an audible alert to remind you to take your tablets. It recognises as you push your tablet through the blister, it recognises a time and date when that tablet's pushed out of the packaging. And as a result, when you go back to the doctor or the pharmacist and you still have the same condition you were being treated for, well, the pharmacist can interrogate the packaging and say, well, you didn't take the tablets every 2 hours, you took them every 4 hours, and then you forgot to take some then, and then perhaps put you on a stronger dose. But it's an understanding there of why the treatment's not worked. I'm going to use this as an example of a happy accident. I'll let the video run. So this is one of our earlier patents, and we trod into it completely by accident. We're not in the business of producing electronic greetings cards, as an entire industry can already do that, and they're manufactured by hand and wired and so on and so forth. And they're at a price point of about $5, $6. I buy them for my better half every year. The customer doesn't care about the fact it's printed or whether it's wired. What we're demonstrating here, and we produce the birthday card as an example of a demonstrator. This traces back to a piece of work we were doing in the office, and I got one of my colleagues, and she was hand mounting LEDs onto some printed tracks that we produced elsewhere. And we got the printed tracks attached to an oscilloscope for some reason in particular, and she was hand mounting these very small LEDs with a pair of tweezers. Quite frankly, if you squeeze the tweezers too tightly, that small LED flies across the other side of the room and you're never going to find it again. And she spent all afternoon flicking LEDs around the office. And she was starting to get a bit annoyed at herself, and so every time she fired one off at the other corner, she'd start sighing. But we had the tracks attached to oscilloscopes, so we could recognise a resistance change suddenly as she was starting to sigh, and we suddenly realised that what we'd actually got was, effectively, it's a printed moisture sensor. So if I run the video again, we created the card around what we'd... We created the card to demonstrate what we developed. So as Maria's breath hits those two printed tracks, the electronics we got attached to there recognises the moisture, recognises the resistance change, and of course, back to designing a consumer experience. When Maria blows at the cupcake the first time, it doesn't blow all the candles out; it only blows two, and we've designed it so you got to blow a second time to actually hear the music. But that's one of those happy accidents. I'm particularly excited, and that's just a printed sensor from two simple tracks. So this is a flexo printed label. The electronics at the bottom is particularly large, but it's a development board we were using at the time. Label's 50 microns thick with a piece of paper over the face of it. And basically the client wanted to see if we could print multiplex keys. So all it's doing is sending a wireless signal to the iPad, and we've got an app running on the iPad that's receiving the signal, recognising what's been touched on the piece of print. But that starts to get interesting in that from physically interacting with a piece of print, we can we can create digital signals, we can affect things in the digital world. Here's a very simple one. I'll go into Bluetooth and some of the wireless technologies we use. This is an obscenely simple invention in that the piece of card there, the electronics on there are incredibly inexpensive. It's a small piezo speaker. It's a little microprocessor sitting on there that recognises the capacitive touch. The app we've written on the smartphone is not connected through Bluetooth. It's not connecting by Wi-Fi. It's simply, for each of the different characters on the buttons, let me just run it back forward again. For each of the different characters touched on the piece of print, there's a very, very quiet tone generated, and each of them are a slightly different frequency. And effectively, the app sitting on the smartphone is, for want of a better term, it's a microphone working as though it's a guitar tuner. And so depending on what touch point you're touching, it's sending a different type of frequency response. The phone's recognising that. It's audio purely. The phone's recognising that and coming up with whatever you've touched on the screen. Incredibly inexpensive, can be incredibly inexpensive in large volumes. Then we get to the interesting things. All of the videos on here I've taken myself, so the production quality is dreadful, but I'll explain what's happening here. So Maria's touching a piece of paper. Difficult to see, but on the iPad, these numbers are increasing according to what Maria's touching on the piece of paper. This is a few years ago, and this is quite an exciting moment for us. To the best of my knowledge, and I could be incorrect in this and be corrected, to the best of my knowledge, that's the first piece of paper ever on the internet. So what the piece of print is doing is recognises Maria's touch as to be yes or no. It's sending a Bluetooth signal to a computer that's not visible on the screen. That computer's on the internet, and it's basically affecting an online database. The iPad that she's holding in her hand is simply holding a web browser, and that page is refreshing every so often. So from her touching the wall, the piece of paper on the wall, she's affecting a database that's online, and she's demonstrating it through the iPad screen. But that opens up some really exciting possibilities. We won a couple of awards for this one. This is a piece of flexographic print, a label just stuck onto the outside of a carton. In fact, we might need the volume up just a little bit for this. So here's a printed circuit. In fact, I'll pass this round. Here's a printed circuit that's so when the user's touching the different instruments on the printed label, it's just sending a signal to the iPad or the iPhone to turn on or off, or toggle on or off that particular instrument on the music track. These are intended as demonstrators of the technology, not intended perhaps as products, to be clear. Again, similar technology. We decided it would be a good idea to take a flexo printed label and make it the iTunes controller. It's quite quiet, this one, yeah. So within iTunes on the device, we can scroll forward, backwards, increase or decrease the volume. And similarly, we can run a jukebox. It's exactly the same label, right, with just a different piece of graphics printed over the top. In fact, I'll pass this around. I'll pass this round because I get used to presenting or working in a place with lots of noises happening in the background. So this is what we call our audio poster. But basically, it's a printed piece of screen print with a very, very simple actuator attached to the back of it. There's some quite hefty batteries, but I've got those there as a demonstrator unit. So as you touch the drums, it plays a particular drum sound. Similarly, I met a colleague whose entire business was designing 3D structures, and he saw the drum poster, and he creates 3D structures, exhibition furniture and so on. He had a table, an octagonally designed table, and he thought it's wonderful. Handed me that and said, could we make a steel drum demonstrator? So I said, well, we can if you go out and record the steel drums for us. So it's difficult to see the structure of the drum within the steel drum there, but it's octagonal and fitted together and all works perfectly. This is a project. Some of the things we've been working on for a while with clients are starting to be released. Which this was released a few weeks ago. So this is with a client, an agency who was working on behalf of Schwartz, the spice company. So they had a television advert that had
what makes this ink special?
Large buckets of spices explode and so on, and they wanted to print an interactive poster to reinforce the campaign.
The idea is that beautiful chords of a piano actually play from your mobile device, and each plume is connected to a different chord, so if you were to swish your hand all across it, it would kind of have an explosion of sound. So what we've done here is create an interactive poster that works off a Bluetooth platform. Effectively, your mobile phone becomes the speaker. Everything now seems to be on an iPad or an iPhone or looking at on the screen. In a way, we've kind of hacked paper. We're trying to figure out a way of getting that interactivity back into print so it works hand in hand with the digital world.
So that was with Schwartz. Again, this is running currently in New Zealand.
This grew out of something I saw online and wanted to use for Bex, and I thought it would be a great way to combine graphic design with electronics and interactivity in a way that people haven't seen before in New Zealand.
This world-first technology uses conductive ink to detect the touch of a hand on a printed poster. Combining that with a flat panel speaker gave us the Bex Playable Poster.
I'm a Bex Playable Poster, an exciting new interactive technology being used for the first time in New Zealand to connect you with new music.
Bex Playable Posters will be appearing on popular music street poster sites and at Bex venues around the country throughout New Zealand Music Month.
So they've actually got these, we created it to be waterproof and laminated. They've got these large A0 posters on the streets of Auckland and I think Christchurch and Wellington at the moment, and they're busy filming them and putting them up on the Facebook page. So this is taking the technology just a step further, and we're currently in production with this. So it's a set of printed DJ decks that are communicating with the software on an iPad. So by interacting with the print, you can spin the record, flick between different tracks. There's I don't claim to know anything about hip-hop or scratch music whatsoever, but we've got an artist approached us, and we're in production to try and put exactly what you see here into a double gatefold piece of album packaging. So the record comes with a set of DJ decks that you can connect to your iPad. Now we do various other things. I mentioned before about embedding LEDs onto print. We're actually working to embed LED dye as well, which is basically the contents of the surface mount LEDs that everybody's probably come across. That starts to be very interesting in that we can embed LED dye into self-adhesive materials and effectively create LED stickers. That's still the development stage for us. This is where we get into what I think is really exciting work. So you've got the example of the drum poster kind of moving around, just mindful of time. There's a single layer of print. You've all seen the label I've handed around where there's a single layer of print, and you can see where the capacitive touch points are. What you're looking here is a double layered, so it's two laminate layers of conductive ink. We've coloured them in this example so that you can see them clearly. There's some grey and there's some black ones. Basically, what you're looking at here is a series of horizontal diamonds all connected, a series of vertical diamonds connected. And in the same way that the piece of print there recognises the presence of your hand when it's over the discrete touch point. What we can do with this is I can recognise with the electronics the position of the XY coordinates. The XY. Is this working? That's great. The XY coordinates of your finger. So that starts to become really interesting in that the mouse in front of your laptop screen, your trackpad, this is exactly what it is, except we're flexo printing it on 23 micron thick PET. And of course, there's things you can do once you can produce and recognize the coordinates of where the finger is or where the finger's moving to. Actually, I'll just run this quickly. I've only included this in here to show and demonstrate, we're talking about making these things at production speed. Actually, that's running slightly shy of 60 meters a minute, but a real press, real time. The things you can do with that XY touchpad, with a Bluetooth chip, and mapping out of the software, it turns into a QWERTY keyboard. We're on with, at the moment, making that QWERTY keyboard also be a trackpad as well at the same time. So it's a single layer of print that can be the QWERTY keyboard, the trackpad, and of course by a simple change of graphics, it changes from being a QWERTY keyboard to being an AZERTY keyboard or a Chinese or a Korean keyboard. Simple remap of the software. Similarly, I showed you before we're doing the DJ decks with some discrete touch points. we're not doing this yet. We're not doing this with the first release. But you can also see with an XY touchpad that it's a case of mapping out within the software recognition of where your fingers are, and suddenly we don't need to print a discrete DJ deck. We just map out the DJ deck in the software. Again, we're not fully underway with this, but I've carried out a couple of trials of printing. This isn't strictly speaking transparent. This is an XY touchpad similar to what I've just shown you, but instead of big solid blocks, we've got 2 layers of laminate with very, very thin, particularly thin a honeycomb structure of conductive ink. The idea being you can see through it. It's not truly transparent because the silver ink we're using isn't completely transparent itself. This is not designed to be competing with touch screens or your smartphone screen. It's genuinely trying to find ways of putting interactive technology in the XY touch technology into things at the moment that don't normally have it at sensible costs. And to finish up, we're doing some research into some of the materials I'm using are horrendously expensive. When I'm using silver inks, the pigment in there is silver. Quite expensive material, so we're investigating ways of producing conductive inks using some very, very novel materials. Graphene is a particular area of focus in that I can bring the conductivity level up of a carbon ink quite significantly by introducing graphene in as an additive. And that's it. Yeah. Are there any questions? Thanks.